Hello, hello. We're working on some data collection, and specifically, you guys got introduced to two-way tables yesterday, although technically it was today, but I'm recording the video late at night. Anyways, so we're going to teach you some vocabulary. We're going to also go over some examples of what two-way tables are. So here we go. 9.2 two-way tables. It looks like a 5 backwards. Okay. We're going to have some vocab. We're going to have 3 vocabs, so make sure you have that pink highlighter out. Yeah. All right, here we go. So two-way table. Let's define it. And I started talking about two-way tables as organizing one thing 2 different ways. But really what you're organizing is the data that's collected. So it organizes one, technically it's called a source. And I kept saying thing. So the example I used in class was shoes. How would you organize shoes 2 different ways? And you guys gave me all kinds of examples of like color, style, brand, what you use them for, old to new, the cleanest, all kinds of examples. I'm a little tired. My brain's a little fried. But it organizes one source in 2 different ways. Now remember, what it organizes is actually the data of it. 2 different ways. That says organizes one source, which is the shoes, okay, in 2 different ways. And so it's specifically, now you're talking about the number of size 10 shoes, the number of Vans you have, the number of flip-flops you have, that kind of a thing. So 2 different ways, the data. Now, in the two-way table, you have 2 different type of totals. Well, sorry, one total, and you have another entry, but they're both called frequencies. And so the first one is called a joint frequency. These are super, super bougie way of just talking about entries and totals. It doesn't look the best, but joint frequencies. Okay. Now, this is just each entry into the cell. Now, in a table, I'm actually going to draw one. I'm going to be referring to the book, but I do have to draw the table. So it's each entry in a table. So for example, the number of black shoes you have is 5. Well, that joint frequency 5 tells you how many is. And you might hear me say it's each entry into a cell. So if you make a two-way table in Excel, Microsoft Excel, or in Google Sheets, each entry is called a cell. It's where you enter information. So I might be saying that as well. So joint frequency is just, each entry. Now a marginal frequency, like I said, this is just it's just a super extra fancy way. Okay, so marginal frequency, what that is, that's the total of each row and each column. So joint frequency is just each entry, but the totals for each row and each column, that's called a marginal frequency. And yes, they actually do refer to these on your big exams. I've seen that multiple times with multiple curriculums. So that is your 3 vocab terms for two-way tables. You know what color to do that. Should not have to be telling you this by now. Okay, so example 1 is going to be, you're going to read a two-way table. So what I'm going to do is I'm going to copy the table that is, I'm looking at the book right now. It's written above example 1. So make sure, I forgot to tell you, make sure you guys have your textbooks out as well. But I am going to be copying it. So here we go. I'm just going to do this real quick. So, okay. So we're organizing students. Okay. That's the one thing we're organizing. And whether they studied or not, and what their grade was. So read a table. And then I'm going to go studied, didn't study. And my kids, you can copy this or not. This is up to you, but it's hard for me to say, oh, look at that, when I should have it up here. So, and then whether they passed or failed. Okay. Okay. So they're going to ask you to read this. And so specifically example 1 says, how many of the students in the survey above studied for the test and passed? So first thing first, if they studied, well, we have 2 options. Well, we want studied and then they passed. So you can go to study and pass. So that would be 21. If I ask you what this 6 represents, you would say that would be the number of kids who didn't study and failed. If I asked you what this 2 represented, that would be the kids who passed but didn't study, which I never recommend not studying. And last but not least, this 1 would be how many kids who studied and failed. And as we all know, sometimes that happens in life. Okay? And example 2, I'm going to still use this 1 table. So this is example 1, and then I'm just going to kind of adjust your title here. Example 2 is you're going to find your totals, which, so I'm just kind of writing it right next to it because there's no sense in copying this table again. So if they're asking you to find the totals in a table, they're asking you for your marginal frequencies, which means you got to find the total of each column and each row. So doesn't matter which order you go in. So if you want to find out the total number of kids who passed, you can go 21 plus 2 equals 23. Sometimes you might see me do this, 21 plus 2, and it equals 23. You don't have to, but that might help. And then, so most time you see this column as totals. To be honest, I don't think I've ever seen it listed as marginal frequencies, even though your book just says total. Okay, so now the total number of kids who failed, 1 and 6, so 1 plus 6 equals 7. Now let's go columns. Okay, so if I want to know the total number of kids who studied for this test, whether or not they passed or failed, it's going to be 21 plus 1, and that equals 22. Should really draw my 2's the same way. And then you do the same thing for the number of kids who did not study, regardless if they passed or failed. So it'd be 2 plus 6, and that equals 8. Now this 1 box right here, that is what we call the grand total, which is the number of kids in this study. So remember, the number of kids is broken into 2 different categories, whether they studied or didn't. And some of you guys might say, well, isn't that 2 categories? Well, no, it's 1 category, but 2 different data, whatever. And the other one is if they passed or failed. So when you add this up, 23 and 7 should be 30. But then when you add it this way, 22 plus 8, that's also going to be 30. Why? Because there's 30 kids in the study. And we just broke it down 2 ways, whether they passed or failed, and whether they studied or not. So you actually do not have to do this twice because it's supposed to be the same number. This right here, that is the number of people in the study. So go ahead and write that down. Number of people in the study. If you want to think about it as like the grand total of kids, that's fine. But 30 kids. So if you ever have to find the totals, and when you add up totals this way and totals this way, and if they're not the same down here, then you did something wrong somewhere, whether it's in a column or a row. But it's easy to check. You just go back and you would just re-add them up. So, okay. So we're going to look at another table. I'm going to erase this real quick. If you want to get started, I'm going to be copying the table that's on your own, OYO number 1. Tables. Okay, OYO 1. Okay, so it says you randomly survey students in a cafeteria about their plans for a football game and a school dance. So you're still organizing students. The two-way table shows your results. Okay, so we want to know, first of all, football game. So basically, are they going to the football game or are they not? So, and they're doing attend. Oh, I need more room. I'm just going to put yes, they're going. No, they're not. Okay, yes, no. And then, row-wise, they have dance. And you guys can copy this or not. That's your call. Dance. Yes, they're going. No, they're not. Okay. So basically, yes is they're attending, no is they're not attending. So let's go here. I'm just going to copy these down. Okay. So there's 2 questions they ask you, but I'm just going to kind of go on my own here. So I want to know how many kids, according to the table, are not going to the football game, but they are going to the dance. So follow for football, no. Follow that down until you hit the yes row for the dance. So no for the football, yes for the dance. So 5 kids are not going to the game, but they are going to the dance. Okay. How many kids are not going to the dance, but they are going to the game? So yes, they're going to the game, but they're not going to the dance. That'd be 16. This does not look like a no. There we go. Okay. So now I'm going to throw you a curve. How many total kids are going to the football game? What'd you guys come up with? Hopefully you said 51. Because notice I didn't ask about the dance. I just want to know how many kids were going to the football game. So 51 are going to the football game. So if they don't ask about another category, then they're asking about a frequency, believe it or not. So I do the same thing. How many kids are going to the dance? And it does not matter if they're going to the game or not. Just how many kids are going to the dance. So you're going to look across the yes, add those up. You should have 40. Okay. Let's go. How many kids aren't going to the game and they're not going to the dance? Maybe they're sick, or maybe their friends aren't going. Maybe they're going to a concert. I don't know. Maybe they're going 4-wheeling or something. Maybe they're out of town. So not going to the game and not going to the dance, 20. Okay. How many total kids are not going to the football game? Not going to the football game. Doesn't matter about the other part. That's 5 and 20. 25. Okay. And then how many kids just aren't going to the dance? Doesn't matter if they're going to the game or not. Add those 2 up. 36. So now remember, this right here has to be the same number horizontally and vertically. So let's just double check that. So 40 and 36, that is 76. 51 plus 25 is 76. So we added everything up correctly. Okay. So if you ever just kind of want to double check this, that's what I would do over here. Go, okay, the sum of these guys is 76, or sorry, 76, and the sum of those guys is 76. Because remember, you're not supposed to use the number twice down here. Because if you actually have a 76 and a 76, you're saying there was 152 total people in the survey, but there's not. That's why you only want to write it once. Okay. I feel like you guys caught on pretty well to two-way tables. Well, most classes. I didn't see you guys yesterday either, and I apologize. 5th period, that's kind of hard. I'm sorry. Okay, so that's stage 1 of being able to interpret a two-way table. Stage 2 is actually now doing something with those numbers, because remember, in data, the whole point of collecting data is to, what I say, big words, extrapolate from that. So you're going to take some meaning out of these numbers. What does this really mean? What does it mean if I have 26 kids not going? Whatever, that kind of thing. Well, it might help make, I don't know, I want to say projections or something like that. Yeah, projections for the next year or something like that. So that's why it's important when you gather data, it's important to take meaning out of it. It's important to analyze it. That's why I went over your STAR test with you, because it's important. Okay? There we go. So example 3. We got 2 more examples. You're going to make a two-way table. So when you make a two-way table, remember, you're thinking one thing organized 2 different ways. Okay? Here we go. So example 3 says you randomly survey students between the ages of 12 and 17 about whether they ride the bus to school. The results are shown on the tally sheets. Okay. So I'm surveying students between the ages of 12 and 17 and whether they ride the bus. So the one thing I'm organizing, my source is students. The two ways I'm organizing that is by their age and then whether they rode the bus or not. And tally sheets, as a reminder, these are tallies, okay? Every time you see 4 and 1 across, that's 5. I don't know if you guys are taught tallies. I don't know, but I just want to go over that with you, okay? So here we go. Normally in class, I have you guys call out the numbers, okay? But we're going to organize students. Now, it does not matter whether you put your age brackets, because at the tally sheets in your book, it goes by age brackets of 12 to 13, 14 to 15, and 16 to 17. So those are going to be your 3 age brackets. And then whether they rode the bus or not. So it does not matter if you put the ages this horizontally or if you put the ages vertically. Doesn't matter, okay? For me, my brain went horizontal. Let's see what they do in the book. And they put it vertically in the book. Doesn't matter, okay? But I'm going to do them horizontally because that's what my brain did first. So 12 to 13, 14 to 15, 16 to 17. And you are going to have to do totals, okay? So that's what the first 3 rows looks like. Well, technically 4 rows, okay? Now, the 2 up here, it's going to be whether they ride the bus or they do not ride the bus, okay? So, rides bus and no bus. And then a total. Okay, so let's do this. So in the first tally sheet for the number of kids who ride the bus. So the 12 to 13, there is, oh my gosh, 24 kids who ride the bus. So I'm going to go ride the bus, 12 to 13. That's going to be 24 right there. Okay. Next one, still riding the bus, 14 to 15. So I'm going to go this column. 14 to 15, does that look like 12, I think? Yes, it's 12. It's really small. And then the total number of kids, 16 to 17, will ride the bus. Wow, is that 13 or 14? I'm going to go 14. Okay. So that's the total number of kids who ride the bus, and it does not matter what their age is. Okay. Next one we're going to do is the number of kids who do not ride the bus. Let's start with age bracket 12 to 13. So this is the next tally sheet, the sheets that look like that stuff. So 12 to 13 that do not ride the bus. Looks like 16. Okay. 14 to 15 that do not ride the bus. 13. And kids who don't ride the bus who are 16 to 17. 21. Okay. And so before we even actually do anything, you could try and figure out, well, what's happening here? Like, why is this number so high and why is that number so high? Okay, well, 12 to 13, number of kids who ride the bus. What could be something that affects that? Well, they don't have a license. Maybe they're riding with older siblings. Maybe all their parents were. I don't know. But here, we should kind of figure out why kids who are 16 to 17, well, there's a high number of them who don't ride the bus. What's the one thing that can happen when you guys are 16? And that's to get their license. So that could be why there's more kids that don't ride the bus, because they're either having they either have their license or they're riding with their friends who have their license. Okay, so we made a table. That includes marginal frequencies. Okay, so now let's add them all up. Here we go. It doesn't matter which way you add, okay, whether you want to do columns or rows first. Let's go across. So 24 and 16, 40, 12, remember you're just adding. 12 plus 13 is 25. Add these guys, 14 and 21, 35, okay? Remember what that guy is down there. That bottom right-hand corner, that's the grand total of number of kids in this survey. Now add them up down here. So 4, 4, 8, 10, carry the 1, 2, 3, 4, 5. Guys, check my math on that. 24 and 12 and 25. Yeah, 50. And then do the same thing here. 16 plus 13 plus 21, 6, 7, 8, 9, 10, 0, carry the 1, 2, 3, 4, 5. Oh, well, isn't that convenient? I just realized that 50 kids ride the bus and 50 kids do not ride the bus. Does that seem weird? Yeah, I'm going to be honest. That does seem weird. Out of 100 kids, literally half ride the bus and half don't. Okay. Now, so we know this is 100. Let's just make sure this equals 100. So 40 and 25 is 65. 65 and another 35 is 100. Okay. So 100 kids in the study. Okay. And so that was example 3. Now, in example 4, what we're going to do is we're going to use this information and take it a little bit deeper. We're not just going to go, okay, this is how many people rode the bus who didn't ride the bus. This is how many kids, this is how many people were in this age bracket or in this bracket or whatever kind of thing. What we're going to do now is we're going to talk about percentages. And that is example 4. And I'm going to keep my table up. So example 4 says, find a relationship. Meaning, does the age have anything to do with whether they rode the bus or not? Okay. So it says, for each age group, what percent of the students in the survey ride the bus to school? And how many do not ride the bus to school? And it says, organize the results in a 2A table and explain what one of the entries represents. Okay. So what are we doing? Each age group, that's where we're going to start. Each age group, I want to know percentage of kids who ride bus and do not ride bus. Okay. Each age group, we're going to find the percentage of kids who ride the bus and who do not ride the bus. My handwriting's getting harder and harder to read, especially backwards. Okay, and we're going to organize it in a 2A table. Okay, here we go. You can recreate this whole thing. I'm going to do a very small scale here, okay? Because I want age bracket. So, for each age group, the percentage of kids who rode the bus. Okay, so rides the bus. We're looking at this column and that column. We're going to take it one at a time. Rides the bus, but it's based off the age bracket. And why is that important? Because I didn't give you a chance to think about it. The reason why it's important to know it, we're going by the age bracket, is because we're not taking it from a total of 100. We're taking it from the total of each age bracket. So if I want, like I said, I'm going to recreate this really small. 12 to 13, 14 to 15, 16 to 17, and I'm just going to keep it really simple. Bus, no bus. Okay. So how about a calculator? If you don't have it yet, you don't necessarily need to go get one. That's fine. Just follow along. I have mine. Boy, I'm tired. It was a long day. Okay. What are the total number of kids who rode the bus in age bracket 12 to 13? Up here, 12 to 13, there's 24. Out of how many kids? It's not out of 50. It's not out of 100. It's the number of kids in this age bracket. So 24 out of 40. Oh, I didn't give myself much room. Okay. So, rise the bus. So you're going to go 24 on your calculator divided by 60. 40, 60. Sorry, long day. 24 divided by 40. That's much better. Okay, so I'm going to rewrite this because I need more room, but you're going to put 24 out of 40, and that's equal to 60%. Really small in there. Now your calculator says 0.6, okay? Move the decimal twice to the right and add a percent sign, okay? So 60% of kids between the ages of 12 and 13 ride the bus. So if they do not ride the bus, that's 16 out of 40. Do I have to do that math? Hopefully you said no, because there's 60% here, and if I want 100% of the kids who are 12 to 13, well, what's 100% minus 60%? That's going to be 40%. If you don't believe me, then go 16 divided by 40. 16 divided by 40. Oh, so weird. Can you see that? There it is, 40%. Okay. So these two have to add up to 100% because it's 100% of the kids who were surveyed between the ages of 12 and 13. Now you're going to do that for all age brackets. So 12-year-olds, whoops, 14 to 15-year-old, I felt like Josue right there. Sorry, bud. So 12 kids out of how many kids there are 14 to 15? What does I say? 25. Okay. So 12 25ths. Now you can do that on a calculator, or since your denominator is a factor of 100, you could just multiply at the top and bottom by 4 and get it. So 12 times 4 is 48. So 48%. Okay. Now 14 to 15 of kids who do not ride the bus. So that is 13 out of 25. You can do the math, 13 divided by 25 on your calculator. Or, what's 100 take away 48? Hopefully you got 52%. If you don't believe me, 13 divided by 25. Or just multiply by 4. Look at that. Boom. Okay? We're almost done. Remember, both of these are supposed to add up to 100%. Okay? All right. 16 to 17-year-olds of kids who ride the bus. 14 out of how many total of the age bracket? Remember, we're not using that number. We're using the total for this age bracket. So there's 35, which means there's 35 kids who were surveyed in this age bracket. So 14 out of 35. Okay, calculator, 14 divided by 35. 0.4, move it twice to the right, so you get 40%. Still write the fraction. For the next one, you have 21 kids who do not ride the bus out of 35 in that age bracket. You can do the division. 21 divided by 35. 0.6, which is 60%. Or if you remember my cute little trick, 40%. Remember, you have 100% of kids in this age bracket, so 40 from 100 is 60. Okay, so this is finding a relationship, meaning now we have percentages, so we've actually done more with the data. 60% of the kids between the ages of 12 and 13 ride the bus. And so part A says, explain what one of the entries means, what it represents. Okay, let's go this guy. 52% of the kids ages 14 to 15 do not ride the bus. There it is. It's the same way you read it up here, except for now you're just reading the percentages instead of the totals up here. So 40% of kids between the ages of 12 and 13 do not ride the bus. 40% of kids between the ages of 16 and 17 ride the bus. Okay. Our next part. Part B says, does the table in part A, this is part A, show a relationship between age and whether students ride the bus to school? What do you guys think? So you're looking at, what you want to look at is the percentages. Okay. What do you notice? Are they increasing? Are they decreasing? Well, if that's too much, think about whether they ride the bus. 60%, 48%, 40%. So that's all decreasing. So that's telling me as the age of the students increase, the number of kids who ride the bus decreases. Kids who don't ride the bus, 40%, 52%, 60%. So that shows a relationship too, because as the age of the kids increase, the number who ride the bus decreases. Okay? Because, sorry, increases. The number of kids, as the age of kids increase, the number of kids who do not ride the bus increases. Had that backwards there for a second. I apologize. Okay? So remember, when you interpret something, you are putting meaning toward numbers. You're going from one language to the next. So yes, it does have a relationship. There is a relationship, and it shows generally as the age of the kids increases, the amount that ride the bus decreases. Okay? I believe that's it. And that is it. That's 2A tables. Hopefully it was pretty okay. 30-minute video, not too bad. Have a great day.